Hello guys. So in this video I am going to give some examples for static cast in C++. In previous video we have seen about an introduction about what is static cast. Now we will see a code example where we can use static cast. For the example I have defined few classes base, which is having fun function, is printing base and member, and derived is derived from base class. It is also having fun function, is printing derived, and member variable is printing, and I'm having unrelated class which is also having fun function and it is printing unrelated, and it is also printing its data member. So these base and derived are in their inherit, they are derived is inherited from base, and so this base and derived are related, but this unrelated is not related to any class. So, and I have created another class as sample which is accepting string as parameter for its constructor. So we'll see about some of the examples for static cast. So as I already told you, the static cast is the combination of either implicit conversion or explicit, like user defined conversion, or combination of both. So here I am going to convert character to integer. So here implicit conversion happens, but so here we can use the static cast to explicitly show in the code that we are doing casting. So if we run this code, okay. So if we print this I, you will get the ASCII value of character 1. So similarly, we can have float. So if I do static cast of this float into int, so here also we can use static cast technically, so in the code that we are doing static cast, and these are all implicit conversions. So now I will show explicit conversion. So I am creating a sample object and which is accepting. So here if we compile this code, don't compile because we are not able to assign this const char array to this. But here we can use static cast. So here what happens is it will try to convert this uh, array, this character array to string. So because here it is expecting string, so it will, the static cast will convert this to a string, and the string will be passed to the sample and it will create the sample object. So this is the for example for user defined conversion. So here I can print some, so here I can just so I can add the print statement. I can show you that here it is converting this char array to string and string is converted to the sample. So this is the implicit and explicit type conversion. So here we can use static cast. Then where now we can use the static cast. So I will comment out this code now for now. So we can use this in inheritance hierarchy also. So that's why I have created um, base class and derived class. Okay. So I am creating a base class and derived class, and I am calling this one for both the objects. So we can just see it is printing base level and derived level. If you see the class, so I created base, I created derived, so it is printing this. So now I am trying to use static cast, and I am going to convert this base. So I am going to do static cast, and first I am going to convert this derived to base, and I am going to call fun function. Okay, so let's see what is output. So it is printing base. So I'm converting the derived object to base, and I'm calling the fun function. So it is calling the base. So here what happens is this derived is inherited from base. So only that base part is sliced, and that function is getting called. So now I'm going to type like do static cast this base object to derived object, and I'm going to call this fun function. Let's see what happens now. See, it's showing error, no matching function for call to derived of base. So it is expecting a constructor which accepts base object as parameter. So it is showing that function is not available, that's why it is failing. So here casting is not happening because, as I already told, static cast can be used only in compatible data types. So compatible data types means this base and this derived are compatible, because derived is data type derived data type which is in the inheritance hierarchy. So derived is the like derived object. So we can convert derived to base, but base to derived we can't, because derived will be of more uh, memory. So it may take 8 bytes when we, but base is of 4. So if we try to convert 8 to 4, it is fine. But here base is 4 only, but we are trying to convert that to 8. It's not possible, right? So that's why we are getting this error. So if we introduce the constructor inside the derived and which accepts base object as parameter, then this code will work. But this is not casting. It is just creating an object of derived which accepts base base object. So this is won't work because incompatible data types. Okay, so this is about normal objects in inheritance hierarchy. Let's try pointers in the same inheritance hierarchy. So I am going to comment this code now. So I am going to create base object pointer, and I am going to create derived object pointer. So I'm going to do the same. I'm going to convert this derived to base, and I'm going to call this fun function. This is pointer, so I'm using the star here, and I'm going to call this fun. So let's see what happens now. It is printing base level. It's normal, we already know. So, but I'm going to do this now. Will it work? In normal object it didn't work, but we are going to try this in pointer. So let's see if it works. So I'm trying to convert this base pointer to derived pointer. Now it's compiling and it's printing derived. But is it printing J? Is it printing the valid value? No. If the object is created, it will be 21. 21 only. But it is printing some random zero value. That means, see, in only the, because here pointers are compatible. The inheritance pointers are compatible. The inheritance hierarchy, the objects in inheritance hierarchy are compatible if they are pointer or reference, but they are not compatible if they are raw objects. That's why here we are not able to cast, but here we are able to cast. So here it is based only. So we don't have a derived object, but we are trying to cast that base pointer to derived pointer, and it is so that time uh, j won't be present in the object, but it is trying to dereference it and just trying to print call this function, and it will call the function derived, but this variable won't be created. That's why some random value is created, is printing. So this is not at all advisable. It will work, but it is very dangerous. It is not safe. So it will lead to runtime errors. So, okay, so now we have so output for this is base 11 and derived 0. So here the output is base 11 and derived 0. Okay, this is for non-virtual function. So this is of inheritance hierarchy, but I have not used virtual. So let's see what happens if I, so this one is overridden in derived, but it is not virtual. But let's see what happens if I use virtual. So here I have got the output base 11 derived 0. So I have just added virtual keyword in the same code and I'm going to run. Let's see what is the output. See, if you see here we are getting derived 21 base 11. It is just opposite of what we have got in previous. So this is the output. So this is the output for virtual function. So why it is happening? Introducing virtual, what is difference? So let's, if so this D object pointer is nothing but derived object. That's why if we create if we have virtual function, a virtual pointer will be created, and using that virtual pointer it will call that function. What is the corresponding function? Derived object. So derived function will be called. So similarly base is in inheritance hierarchy, and it is this fun function is virtual function. That's why using since it's a virtual function, a virtual pointer will be created, and that's why this b is of base and its corresponding base function is getting called. So that's why we are having a difference in the output between virtual and non-virtual function. So thanks guys.